In this numerical, we have to calculate the freezing time of a meatball. We have a meatball and we have to calculate the time required to freeze this. The initial freezing temperature of this meatball is minus 10 degrees centigrade and the surrounding temperature is minus 45 degrees centigrade. And for calculating the time, we have to use the Planck's equation. Planck's equation is equivalent is T is equivalent to latent heat of fusion, which is to be multiplied with moisture content into density divided by initial freezing temperature minus surrounding temperature, whole multiple with P into thickness divided by H. P is the shape constant, and for sphere it is 1 upon 6, and T is the thickness which is given in the numerical. H is the latent heat of H is the this heat transfer coefficient, plus Q, which is again shape constant, and for sphere it is 1 upon 24 multiple with thickness square divided by K, which is convective thermal conductivity. So in this numerical, we to take care of units. We have to first of all we have to convert 100 mm into meter, which will become 0.1 meter, and we have to convert latent heat of fusion, which is 333.2 kilojoules into joules per kg. We have simply we have to multiply it with 1000 to form it joule per kg. And we don't need to convert degrees centigrade into Kelvin, because in this formula it is just a difference of temperature. So whether it is a Kelvin or the degree centigrade, the answer will be the same. So moving forward, one thing you have to take care is the initial freezing temperature. In this numerical, there are three temperatures given. One is 35 degrees centigrade, another is minus 10, and another is minus 45. So uh, the in formula we have to use the initial freezing temperature, which is minus 10 degrees centigrade, not 35 degrees centigrade. So after putting the values in this equation, we'll get time equivalent in seconds. We'll get the time in seconds, which will be equal to 3904.4376 hour. But we have to, sorry, this is seconds. We have to convert this into hours. We have to divide it with 3600, which will be equivalent to 1.08 1.08 hour. So in next numerical, we have to calculate the humid volume. So for calculating the humid volume, we have to use formula for it, and it is humid volume formula is 0.082 into dry bulb temperature, which is given in numerical as 40 degrees centigrade, plus 22.4 multiple 1 upon 29 plus W, which is humid ratio, upon 18. So first of all we have to calculate this humid ratio. For calculating humid ratio, we have to use one more formula, humid ratio W, which is equivalent to 0.622 multiple by partial pressure of water vapor divided by total pressure minus saturated vapor pressure. Saturated vapor pressure is given in our numerical, which is 7.375 kilopascal, and total pressure is 1 atmosphere, which is taken as 101.325 kilopascal, and we have to calculate this. So for calculating this, we have to use another formula. Um, it can be derived from one more formula, which is relative humidity. in in our numerical relative humidity is given as 60%, where the relative humidity is equivalent to partial pressure of water vapor divided by saturated vapor pressure, which is given in our numerical multiple with 100. So here we will get the value of the PW. So PW will be equivalent to 4.425, and we have to use this in this equation, and here we will get then we will get the value of W, which is equivalent to 0.0284, and then we have to put this value here, uh, and we will get the humid volume. We'll get the humid volume as 0.926, which is the final answer of this numerical. Moving towards next numerical. In this numerical, uh, we have to calculate the pressure. Velocity V2. When milk is homogenized, it is passed through a narrow slit, and the pressure from this side is very high, but the velocity v1 is very low, and which is approximately 0, because the liquid flow is stopped, huh? because of the narrow opening. But when it moves out of this, the pressure P2 approximately becomes 0, and V2 increases, and it is very high. So the formula for calculating this velocity is P1 plus plus 1 half of density V1 squared is equivalent to P2 plus 1 half of density V2 squared. Assuming these things, the equation will become V1 equivalent to 1 half of density V2 squared. So putting the values in it, we will get V2 equivalent to 241.355 meter per second. Moving towards the next numerical, which is related to the mass balance. Here we have potato slices which are to be dried into chips, and there is 10% loss, and in the potatoes we have 12% solid content, and the chips, when we dry it, we will get the 94% solid content. So we can say the there is 10% there is 10% loss. So if we take 100 kg of potato, it means 10% is loss. We minus it with 10 kg, it becomes 90 kg, and we can say in 90 kg we have 12% solid, which means 90 into 0.12, which is equivalent to 10.8. So we can say 10.8 upon 90 into 100 is equivalent to 12%. So uh, from the left hand side we can say 10.8 upon x into 100 is equivalent to 94%. So from here we can calculate the x, which will become 11.489. So 11.489 is the exact answer. 11.489 11.489 is exact answer. Hope you understood this. Thank you very much for watching.